All right, welcome to Cruz Learning, where it's just that easy with your favorite professor, Professor Cruz. And today we're going to talk about factoring a special case, which is the sum and difference of cubes. So these will always factor the same way. They're actually pretty fast to factor. Let's go. Let's go on with the rule. If I had a sum of cubes, and this is called the sum first because I'm adding. And it's called of cubes because the first term is a cube term, whether it's a variable or a number, which could be a perfect cubed. And the second term is also a cube. So you're adding two different terms that are cubes. That's why it's called the sum of cubes. And this is very easy to factor. I will open two parentheses, one for a binomial and one big enough to take a trinomial. And the next thing that I always write down are the signs. Okay, so I hope that you are used to this already. The first one, I don't know if you've ever seen a movie called The Interview, but there's one part with one of the characters is describing one nationality with the other at the beginning of the movie, and he says same, but different. All right. So what I'm going to do is that the signs that I'm going to go here, since this is a binomial, I'm going to have to write one sign. So same. The first sign that I'm going to write is the same sign as my problem. So that's where that comes from. Same, but different. All right. Same, but different. And always positive. So you always have to write down three signs. Please write this down. This is going to be the same sign as the original problem. This is going to be the different sign or the opposite, right? So same, but different. And the last sign is going to always be positive because we're all positive in here. Okay, so now what about the variables? What about the numbers? Well, because the first variable is a cubed, this is going to be a, whatever the cube root of that is. Because the second term is b cubed, is going to be b, the cube root of b cubed, whatever that is. And then I'm going to take the first a and I'm going to square it and I'm going to write it first. Then I'm going to take the last b and I'm going to square it and I'm going to write it last. And at the end, in the center, I'm going to combine both of them because they're in the middle, right? So they're going to combine. So it's going to be just a times b. So this is the sum of cubes. Now, how about if I wanted to do the difference of cubes, right? Because this says the sum and difference. Well, my question or my challenge to you is, would you be able to write down the formula? I mean, if you can, it's okay, but I hope that it makes sense. If I have to do a difference of cubes, then I start with the signs. And the sign says same, but different. Always positive. Okay? So notice that I use the same sign, same, but different. Always positive. Okay? So I'm going to do that every single time. I hope that you remember that by the end of this video. All right, so, and again, the variables stay exactly the same. So the first term is a cubed. So the first term of my binomial is just a. The second term is b cubed. So the second term of my binomial is just b. Then I'm going to forget about the problem, and I use this a and b, and I'm going to square the first, write it first, square the last, write it last, and in the middle, they're going to combine, so combine them. Multiply whatever a times b is. So it's very, very important. The most important part in these problems is to identify what a is and what b is. So let's do an example so that you can understand what I'm talking about. All right, example 1. Z cubed plus 1. If I want to factor this, I'm going to have to open two parentheses, right? Two parentheses. One bigger than the other one because the first one is a binomial. The second one is a trinomial. All right, so for the first one, the first thing I'm going to do is I'm going to write the signs. The sign is positive. Therefore, this is a plus sign. This is a sum of cubes. So it's going to be same, but different. Always positive. Okay? Now, I'm going to take whatever a is. In this case, is the first term. what is the cubed root? Or can I take the cubed root of z cubed? Of course, it's just z, right? So I'm going to write this on the side so that you understand that a for this problem is z. Why? Because z times z times z gives me back my z cubed. So that's why I'm taking a cube root. So it's going to be z. What is my b in this problem? Well, it's the term after the plus sign. B cubed is 1, so b is just 1 because 1 times 1 times 1 still gives me 1. So the cube root of 1 is 1. Now I forget about the problem and I only look at my new a and b. And I take the first one and I square it. So this is going to be z squared right at first. Take the last term and square it, which is 1 squared. So 1 times 1 is just 1. And then in the center, I'm going to multiply both of them. So z times 1 is just z, or 1z, right? But because it's 1z, I don't have to write the 1. I just write down the z. Okay, I ask myself if this is completely factor, and it is. So this is my answer. This is going to be my answer right here with the sum of difference of cubes. Let's continue. What happens if you have big numbers? And sometimes you will see big numbers, okay? But it's not that bad. What you have to remember is the perfect cubes, okay? The perfect cubes. So it's 216. Does that number have a cube root? And the answer is yes. The cube root of 216 is 6 because 6 times 6 times 6 equals 216. When I look at the variable, which is t cubed, does that have a cube root? Of course, it's t cubed. So I can automatically write down my a. See, I always have to identify my a. My a is 6t, just 6t, right? So I'm going to open two parentheses. I'm going to open two parentheses, one bigger than the other. I'm going to write down my signs. So same, but different. This is also sum, and this is always positive no matter what. Okay, so I already established that a is 6t, so I'm just going to write down 6t in here. Okay, and then I look at the second term, which is 125. Does 125 have a cube root? Yes, it is 5. Because 5 times 5 times 5 is 125. So this is just 5. I forget about the problem, and I only look at my new a and my new b, which I said that b now is 5, because 5 times 5 times 5 is 125. Good. So now I'm going to square it. What is 6t squared? Well, recall that 6t squared is the same thing as 6t times 6t. I hope that this makes sense. So 6 times 6 is just 36, and t times t is t squared. So this is 36t, I'm going to make some space over here, t squared. Okay, and this was a minus sign. Why? Because 6 times 6 is 36, and t times t is t squared. The last one is b squared. So 5 times 5, right? The last term with the last term is just 25. And I'm just missing the middle. So I need to multiply these two, okay, a and b, to get the middle. So 6 times 5 is 30, or 6t times 5 is 30t. So this is going to be over here. I'm going to zoom in a little bit because so I have enough space. This is 30t. And that will be my answer, that it's completely factor. Okay, as a cube. Okay, so that's a cube. Now let's look at the next one, because the next one is very interesting. Okay, when you look at the next problem, and I ask you, do you have a difference of cubes? Well, the automatic answer will be no. And the reason is because 3 does not have a cube root. There is no number that you can multiply times itself to get 3, right? 3 times. But what that means is that we need to go back to the basics of factoring, which is finding a greatest common factor, the GCF. So what is the greatest common factor of this problem? Well, it looks like it's 3, right? 3 is the biggest number that will divide everything here. So I'm going to factor out of 3, and then I'm going to open a parentheses. When I factor out of 3 and I open a parentheses, I'm going to get x cubed inside because I factor out the 3. There's a minus sign, so minus. And then I'm going to divide the 192 by 3, and that should give me 64. Okay, so when I do factor the 3, I get 64. So I hope that this makes sense so far. But look what happens now. This is a difference of cubes. So I'm going to rewrite the 3, which I'm not going to do anything with in the next step because that's already factored. And I'm going to open 2 parentheses, one bigger than the other. And then we're going to use our tactic. Now signs are going to change, right? Because it's same, but different. All right? Same, but different. And then always positive. Always positive. So here we go. Now, remember, I'm no longer looking at the original problem. Now I'm looking at the factor form of the problem. So I'm looking at this area right here. That's what I'm going to factor. So what is the cube root of x cubed? Well, it's just x. Okay. So that's my first term. My second term is 64. So the cube root of 64 is just 4 because 4 times 4 is 16 times 4 is 64. Okay. And then I'm going to take this x and square it. So square the first term and write it down. That's x squared. Square the second term and write it last. That will be 16. Okay. And now multiply these two. 4 times x is 4x. And that is completely factor. I hope that this is making sense for you. Well, it might not be, so these things, some of them might not be completely factored, but definitely this is completely factored. That's how you factor a difference of cubes. So let's look at the last problem. Are you ready for the last problem? This is going to be the last problem. Very simple, very easy topic, I hope. You have ax to the 4th power minus 125x. So you notice once again that there's something wrong this time with the variables, okay? So 8 is a perfect cubed, 125 is a perfect cubed, but you cannot take a cube root of x to the 4th power and just get nothing, right? Or a cube root of x. So what can I do? I can factor the greatest common factor one more time, okay? But instead of factoring greatest common factor for the coefficient, now I'm going to do it for the variable. So the greatest common factor here is just 1x because I can factor out at least or at most 1x from every single one. That's why it's called the greatest. And when I do that, I'm left with ax cubed minus 125, and that's it. Okay, the first part is a cubed, perfect cube. The second number is a perfect cube, so I could definitely do this. I'm going to write down the x outside that I'm not going to use to factor because I already factored it out. And now I'm going to open my 2 parentheses. Once again, one for a binomial and the other one for the trinomial. And you know the rule of the signs. Hopefully you can do it before me. Same, but different. Always positive. Okay, so remember, same, but different. Always positive. All right. So, and now, our feature presentation, taking cube roots. What is the cube root of 8? Well, the cube root of 8 is 2, because 2 times 2 times 2 is 8. So this is going to be 2x, because this is the cube root of x cubed is x. Good. Now I'm going to look at the 125. And the cube root of 125, we kind of did this already. It's 5. We did it in the previous problem 2, I believe. And then that's it. I forget about that, and I only look at my A and my B. Take the first part of the first term of my binomial and square it. So 2x times 2x is 4x squared. I take the last term and I square it. So 5 squared is 25, because 5 times 5 is 25. And then I'm going to multiply them both. 2x times 5 is 10x. So that's how you factor the special case of sum and difference of cubes. This was Professor Cruz with eCruz Learning, because it's just that easy.